Welcome to homework.
I'm going to solve problems 29 and 30 together since they look at the same structure, and they're just asking us to look at the internal force and moment at a couple different points. So in problem 29, they want us to look here, and then problem 30, they want us to look here. So we have this kind of arch structure that's just basically a bent beam that's bent, and then it makes a 30-degree angle here with the horizontal. It is pinned at this end, and then the roller support at this end, and then we have a load at the peak, and then a loads midway along these rising and falling spans that are normal to those spans. So if we look at the whole structure here, we have F1x plus F3 sine theta, the x component, minus F5 sine theta, the x component of this has to be 0. In the vertical direction, here you have F1y minus F3 cosine theta minus F4 minus F5 cosine theta plus F2 equals 0. And now for moments, we have let's see here, we have the moment from F3. So the moment arm, we just basically need to take the moment arm, because it's perpendicular to this. The moment arm this is 3 feet here, so that's the moment arm. For F4, we need this distance here, so that's 6 cosine theta times F4. And then for F5, what I did, and I think I basically need to, I didn't make it clear that this should all be dotted with the unit vector outside of the unit vector in the out of plane direction. So what I did here is just to kind of make it simpler, I guess. I took the vector that to this point as this vector plus this vector. So this is a 3 feet in the BD direction, and then this is 12 cosine theta in the I direction. So what we can do here is that this cross product is easy because F5 is perpendicular to BD, so we just get 3 F5 in the K direction. And then here, and then for this part, we can just take the J component, or the horizontal component of the F5, the force at F5, and because that's the only one that's going to take a cross product with I and be non-zero. So that gives us, I just wrote it this way as a simpler, instead of trying to write this vector here, I just wrote it as here to and then to here. And then finally we have F2 creating a moment at 12 cosine theta units away from feet away from the origin. These 3 equations have 3 unknowns, and they tell us that F1x is minus 100 pounds, F1y is 985 pounds, and F2 is 927 pounds. And that makes sense because this load is bigger than this load. So there's not symmetry in this problem because this has 800 pounds and this is 600 pounds. Now for problem 29, we take a cut here, which is actually simple because we can just look at this region here. So we have in the x direction, we have F1x, and then plus n1 cosine theta minus v1 sine theta equals 0. In the y, we have F1y plus n1 sine theta plus v1 cosine theta equals 0. And then moments, we just have this distance here to the cut is 1.5 feet. So we have 1.5 feet times v1 plus m1 equals 0. And these 3 equations we can use to solve for v1, n1, and m1. And we get v1 equals 903 feet or pounds, n1 equals minus 406 pounds, and m1 equals 1.35 kip feet. And so it makes sense here, if we think about it, that n is negative. And that makes sense because as we kind of push this beam down, it's going to try to, compress these two things. Because if we want to think about, if we want to deform this, these things are going to get shorter. So it's not surprising that this is in compression, and we'd also expect this one to be in compression too. So looking at problem 30 now, we copied the figure over here. So now we're looking at this point here, and we take a cut. We take a look at this region of the beam, and in that region we have, in the x direction, we have minus n2 cosine theta minus v2 sine theta plus f5 minus f5 sine theta equals 0. And in the horizontal direction we have n2 this would be in the vertical direction, sorry, n2 sine theta minus v2 cosine theta plus f2 minus f5 cosine theta. So just these are the y components, and these are the x components of the force vectors. And then moments are easy because we know that this distance is 3 feet. So that's 3 times f5, and then this distance to the cut is 4 feet, so if we have 4 times v2, and then we have minus m2. So these three equations will then give us n2 is minus 464 pounds. Again, it's compressive as we anticipated. And then v2 is 203 pounds, and m2 is 2.61 kip feet.